What if your model could pick its own features, no domain expert needed? When you are working with high-dimensional datasets, feature selection is one of the hardest steps in the entire machine learning pipeline. You have hundreds or thousands of features, and picking the right ones usually means choosing between filter methods that miss nonlinear relationships, wrapper methods that do not scale, or paying a domain expert to tell you what matters. What if there was a way to automate this entirely? That is exactly what GAMPS claims to do. GAMPS stands for Generative Adversarial Network Feature Selection. It is a Python package created by Harsh Patel, released under the MIT license. As of the PyPI listing, it is at version 0.2.1 and is in alpha development status. You can install it directly with pip install GAMPS or grab the latest development version straight from GitHub. The API is designed to feel familiar if you have used scikit-learn transformers before. Here is the core idea. GAMPS trains a GAN exclusively on your feature data. The generator learns to produce realistic synthetic samples, and the discriminator learns to tell real from fake. Once the GAN has learned the underlying data distribution, GAMPS applies a perturbation strategy to the discriminator. It systematically perturbs individual features and measures how the discriminator reacts. Features that are hardest to fake, meaning the discriminator still correctly identifies samples even when those features are perturbed, are ranked as the most important. It is a perturbation-based sensitivity analysis on the discriminator, and it requires no domain-specific supervision. The API is straightforward. You initialize the GAMPS selector with parameters like epochs and batch size. The default is 500 epochs with a batch size of 4,966. You call fit on your feature matrix and labels, then get a feature ranking as a data frame. To select the top K features, you call transform with K set to your desired number. There is also a fit transform convenience method that does both in one step. You can even analyze synergistic feature pair interactions with get feature pairs from data. And like any good ML tool, you can save your trained model to disk and load it later with the GAMPS load method. The research behind GAMPS was published on RZiv in April of 2025 by Harsh Patel. The paper is titled Feature Selection via GANs and focuses on enhancing machine learning models for DDoS mitigation. The experiments were run on the CI/CD DoS 2019 dataset, which is a well-known network intrusion detection dataset. The paper showed that GAMPS not only improved the accuracy of downstream classifiers, but also enhanced computational efficiency by significantly reducing feature dimensionality. The author originally developed this algorithm during research on large-scale DDoS detection, where identifying the right network features is critical. Under the hood, the default architecture uses a generator with hidden layers of 64 and 128 neurons, and a discriminator with 128 and 64. The perturbation mode can be set to dynamic or static, and you can tune the perturbation multipliers, which default to 0.5, 1, 2, 5, and 10. There is also label smoothing for the real and fake classification, early stopping with a patient's parameter, and checkpoint support for resuming training. The learning rate uses the Atom optimizer at 0.001 by default. The community response on the original Reddit post has been thoughtful. One commenter pointed out a real concern. The paper only evaluates on one dataset with roughly 80 features, which is hardly high-dimensional in feature selection literature. They suspect scalability may drop off with truly high-dimensional data of 1,000 or more features and fewer instances. They also noted that since the approach is unsupervised, it should be compared against a random baseline. Another commenter asked whether GAMPS has been compared against recursive feature elimination or statistical methods available in scikit-learn, which would help draw a line at where each method performs ideally. There was also praise for the creative approach and appreciation for sharing it with the community. As of the latest update, the author is actively working on optimizing GPU memory consumption, particularly for smaller datasets. The package is still in alpha, so it is not yet production-ready for all workloads. The author is actively seeking feedback on the architecture, code structure, and any bugs people encounter. If you want to dig into the math or implementation details, the RZiv paper and the GitHub repository both have the full documentation. GAMPS is an interesting approach to an old problem. Using adversarial learning dynamics for feature selection is genuinely novel, and the perturbation-based sensitivity analysis on the discriminator is a clever idea. It is early days and the community feedback about scalability and benchmarking is valid. But if you are working with high-dimensional data and want to try a GAN-based approach, the package is available now and the API is clean. Thanks for watching and check the description for all the links. Thanks for watching. If you want to try GAMPs on your own data, all the links are in the description. Let me know what you think in the comments.